All right, then. So you lot wanted the full lowdown on Apollo 13. Everyone remembers the headlines, of course. But we're going to properly get into the nitty-gritty of this mission, yeah. Right from what they set out to do, what they planned, all the way through to how it actually, well, panned out. Consider this your expert-level briefing on one of the, shall we say, most eventful space flights ever.
Absolutely. And we got quite a lot to go on here. In-depth stuff about the mission from the beginning, right up to when things went a bit pear-shaped. And then all the incredible work that was done to, well, get the crew home safe. So we're going to break all that down, give you the inside track, go way beyond the usual story, yes. Really look at what made Apollo 13 so unique, both in terms of the technical side and the, well, human side of things.
Right. So set the scene for us. April 1970. Apollo 13, the 7th crewed mission in the program, and importantly, it was meant to be the 3rd time they tried to actually land on the moon. And they weren't just aiming for any old spot, oh no. This time it was the Fra Mauro formation. Now this area, it was particularly interesting for scientists because they thought it might have bits and pieces from when the Imbrium Basin was formed. That's a huge crater, right? So basically ancient leftovers that could tell us a lot about the early solar system. Ex luna, scientia, they said. From the moon, knowledge. Bit of a twist on the old Naval Academy motto, but it captures the whole scientific purpose beautifully, eh?
Spot on. And this was the second of what they call the H missions, a step up, even from the earlier landings, more complex. So the plan was precision landing, geological survey, and of course, bring back samples from this very specific place. And on top of that, they had to deploy the ALIS, right? The Apollo Lunar Surface Experiments package. There was a whole suite of scientific instruments, including a seismometer to check for moonquakes, an experiment to measure how heat flows inside the moon, all sorts of other things to look at the environment there, charged particles, the very thin lunar atmosphere, even how much dust accumulates.
What a kit they had. So who are the chaps entrusted with this ambitious little jaunt?
Well, you had Commander Jim Lovell, a veteran astronaut. This was his 4th trip into space. Then there was Command Module pilot Jack Swigert. For him, this was, well, his first, and as it turned out, only flight. He'd been brought in as a last-minute replacement for Ken Mattingly, who'd been exposed to rubella, and then Lunar Module pilot Fred Hayes, also on his first space flight. Interesting mix, really. A highly experienced commander and 2 rookies. A dynamic that would, shall we say, be thoroughly tested. They set off on the 11th of April, 1970. The launch, though, wasn't entirely smooth sailing. The middle engine on the 2nd stage cut out too early. Put it down to what they call pogo oscillations, basically. Unstable vibrations in the rocket structure. Not completely unheard of, but this time it was particularly noticeable.
Yes, rather inconvenient. But the other engines on that 2nd stage, and the SIVB, that's the 3rd stage, they burned a bit longer to make up for it, you know, that final push that gets them away from Earth's gravity and on their way to the moon. And they still managed to get into a pretty much perfect parking orbit. Shows the level of, well, redundancy built into these missions, doesn't it, even at that early stage?
Remarkable, isn't it? So, parking orbit achieved. The translunar injection burn, the TLI, went ahead as planned. That's what sends them towards the moon. Then the transposition and docking maneuver, the command module, Odyssey, turns around, connects with the lunar module, Aquarius, and then the 2 spacecraft still joined together, they separate from the SIVB. Now that SIVB was deliberately steered to crash into the moon. Not just checking out rubbish, mind you. They timed it to hit right when the seismometer from Apollo 12 would be able to pick it up. Clever way to get more data on the moon's internal structure.
So off they went. Everything seemed to be settling down as they began the translunar coast phase. And it's during this bit that you see some of the, well, more human moments. Amidst all the procedures and technical stuff, I mean. There was a mid-course correction burn, for example, to tweak their path. Interesting thing is, that burn put them on what they call a hybrid trajectory, a bit different from the free return path. That was all to allow for the landing at Fra Mauro.
Important distinction that. A free return trajectory would brought them straight back to Earth without any major engine firings. But you could only land near the lunar equator if you did that. This hybrid trajectory, well, it let them aim for places further away from the equator, like Fra Mauro, but it meant you absolutely had to do that mid-course correction burn. And of course, there's the famous story about Jack Swigert realizing he hadn't filed his tax return.
Oh yes, quite a story. Even astronauts have to worry about the tax man, eh? Mission Control's response was brilliant. Well, you do get a 60-day extension for being out of the country. Imagine that, those little moments that, well, remind you, these are just people like you and me, even hurtling towards the moon.
Exactly. And looking at the mission timeline, it looks like they moved up the time for the crew to go into the lunar module and check the systems, twice in fact. Suggests they were being very proactive about making sure Aquarius was in tip-top shape. And then there was the TV broadcast they had planned. About 55 hours into the mission, they wanted to show off Odyssey and Aquarius to everyone back home.
And rather telling, isn't it, that none of the big American networks actually bothered to show it. Marilyn Lovell, Jim Lovell's wife, she ended up watching it in the VIP room at Mission Control. Shows how public interest had waned a bit after the initial excitement of the first moon landing, doesn't it? A successful mission was becoming, well, almost expected.
A sentiment that would be dramatically reversed, wouldn't it? Because just a bit later, at about 55 hours, 54 minutes, and 53 seconds into the mission, to be precise, things took a rather sharp and, well, dangerous turn. They were something like 180,000 nautical miles from Earth, and only about 6.5 minutes after that TV broadcast that nobody watched.
Quite right. Fred Hayes had just finished shutting down the LM after doing those systems checks. Lovell was putting away the camera, and Capcom, Jack Lousmet, he told them to change the spacecraft's attitude. They wanted to get some photos of Comet Bennett. Then ECOM, Cy Liebergott, asked them to stir the oxygen tanks. Routine procedure, usually done every day. You have to mix the oxygen up to get an accurate pressure reading. And Flight Director Gene Kranz, he held off on giving that instruction for a bit, just after the TV broadcast.
The order of events here, this is crucial. Lousmet, he relays the instruction to Swigert. Swigert, he activates the fans in oxygen tank number 2, then turns them off again pretty quickly. 95 seconds later, bang. The crew report a pretty large bang, and along with that, the electrical power starts fluctuating, the attitude control thrusters fire unexpectedly, and for a moment, communications and telemetry, they just cut out. That 1.8 seconds it took for the S-band antenna to switch over, well, I bet it felt like a lifetime to the folks in Mission Control, not knowing what was happening to the crew.
I can only imagine. And then comes Swigert's famous line, often misquoted. "Okay, Houston, we've had a problem here." And right after that, Lavelle, more to the point, "Houston, we've had a problem. We've had a main B-bus undervolt." It was GUIDO, the guidance officer, William Fenner, who first told Gene Kranz in the control room about this serious issue. Things were going downhill fast.
Indeed. Lavelle, at first, he thinks maybe it's something small, like the lunar module's repressurization valve. But he quickly rules that out. Swigert, he wonders if they've been hit by a meteoroid. And again, there's no sign of a leak, so that's not it either. This main B-bus undervolt is a much bigger problem. It means there isn't enough voltage coming from the service module's fuel cells. Now, those fuel cells, they're the main power source for the command module, and they run on oxygen and hydrogen. The voltage does jump back up to normal for a bit, but then it drops again on both of the main power buses. Think of a bus as a main power line in the spacecraft. Under, well, there is like a brownout in your house. But in space, it's a big red flag that your power source, the fuel cells, aren't working right. Hayes checks and finds out 2 of the 3 fuel cells are dead. And that's a no-go for entering lunar orbit.
And the data coming back to Earth, it wasn't looking good either. Tank 2 shows empty, the pressure in Tank 1 is falling, the spacecraft's computer has reset itself, and the high-gain antenna is out. Cy Liebergott, he's looking at Tank 1, and he thinks those readings are for Tank 2. Kranz, always sharp, he questions that. Liebergott at first thinks maybe the instruments are faulty, something he'd be reminded of for a long time to come, I gather.
All these things happening at once, it slowly built up this, well, unfolding disaster. And then Lovell reports seeing a gas of some sort venting out into space. That's it. No more doubt. Something major has gone very wrong. And then it hits them. Those fuel cells need oxygen to make power. If Tank 1 runs dry, the one fuel cell they have left will start using the oxygen from the command module surge tank, and they absolutely need that oxygen for re-entry. Kranz immediately orders them to isolate the surge tank. It's the right call, but it means their last fuel cell will die within 2 hours as Tank 1 empties, either through use or that leak.
And as if that wasn't enough, they're surrounded by a cloud of debris from the explosion. It makes it really hard to navigate by the stars, which is, vital for figuring out where you are and adjusting your course. At this point, any thought of landing on the moon at Fermaro, that goes right out the window. The only thing that matters now is getting the crew home alive. A rather stark and, terrifying turn of events.
It's really amazing how quickly everyone thought on their feet, both up in space and down on the ground. And Kranz's decision to use the lunar module, Aquarius, as a lifeboat, that was absolutely key. Now, they had thought about this kind of scenario beforehand, although they thought it was very unlikely, and they'd actually come up with some procedures, particularly after a simulation they did during Apollo 10. It's sobering, isn't it? If this had happened later, say on the way back or while they were orbiting the moon after they'd already gotten rid of the LM, well, their chances would have been very slim.
Slim indeed. At first, they considered a direct abort, using the service propulsion system, the big engine, to get back quickly. But they decided against it. That engine could have been damaged in the explosion, and anyway, it needed power from the fuel cells, which were failing. So they went for the longer route, the circumlunar trajectory. It would take more time, but it was the safer bet. The lunar module's descent propulsion system, the DPS, it became their workhorse for course correction, not as powerful as the service propulsion system, and importantly, Mission Control had never actually planned to use the LM's engine to move the combined CSM and LM, so the teams on the ground had to scramble to write new software, develop new procedures, all on the fly.
A remarkable display of improvisation, really. And Lovell himself, he played a crucial part. He copied all the guidance information from the command module by hand, did the calculations himself to put it in the lunar module's computer, which had been switched off to save power. Then Mission Control double-checked everything. High stakes, to say the least. That first crucial burn with the DPS, a little over 61 hours into the mission, lasted just 34.23 seconds. Absolutely vital to getting them onto that free return trajectory.
That burn essentially sent them looping around the moon and back towards Earth. However, the initial path had them splashing down in the Indian Ocean. Not ideal, really. NASA didn't have many recovery resources there. Fido, the flight dynamics officer, Jerry Bostick, and others, well, they wanted to get the crew back sooner and in the Pacific Ocean, where the main recovery fleet was. One idea was to ditch the service module early, which might have shaved off about 36 hours. But it was risky. The command module's heat shield would be exposed to space for longer than it was designed for. There were a few other solutions on the table, too.
The final decision was down to Robert Gilruth, the director of the Manned Spacecraft Center. He decided on another DPS burn to be done after they passed their closest point to the moon, what they call parasynthion. They called it the PC+2 burn. This would knock about 12 hours off the total trip and get them splashing down in the Pacific. It really shows the faith they had in the lunar module's engine and the calculations they were making under immense pressure. And just so everyone's clear, parasynthion is like perigee, the closest point to Earth, but for an orbit around the moon.
And so at 7:21 p.m. Eastern Standard Time on April the 14th, Apollo 13 reached its furthest point from Earth. That's a whopping 400,171 kilometers. Still a Guinness World Record to this day. And as they were getting ready for that crucial PC+2 burn, they got confirmation that the SIVB, that third stage, had hit the moon as planned. Lovell's comment, well, at least something worked on this flight, rather sums up the situation, wouldn't you say?
Understatement of the century, almost. For the PC+2 burn, it was Kranz's white team who took over the consoles. They'd been the ones who came up with the emergency procedures right after the explosion. And navigating, it was incredibly difficult. All the debris around the spacecraft made it hard to use star sightings to figure out where they were, so they had to use the sun instead, which isn't easy. Houston was constantly guiding them, giving them updates. And remarkably, the view of the moon from the lunar module commander's window was almost perfect. A stroke of luck, really. It helped a lot in figuring out their orientation. The burn itself started just over 79 hours into the mission, lasted 4 minutes and 23 seconds. After that, they shut down most of the LM systems to save what little power they had left.
They were on their way back, but the next big challenge was keeping the crew alive until they got there. And one of the most pressing issues was getting rid of the carbon dioxide building up in the lunar module. Now, the LM's lithium hydroxide canisters, those are what scrubbed the CO2. They were designed for 2 astronauts for about 45 hours on the moon, not 3 men for days on end. The command module had plenty of the right canisters, but they were the wrong shape, wouldn't fit the LM's environmental control system.
This is where the engineers back on Earth really showed their brilliance. They came up with this thing called the mailbox. It was an adapter, basically cobbled together from plastic covers, from manuals, duct tape, whatever they could find on board. SheepIcom, Joseph Kerwin, he talked the crew through it step by step. And Swigert and they built the thing, worked to treat CO2 levels dropped right away. Lovell called it a fine example of cooperation between ground and space. And he wasn't wrong.
Another crucial problem was water and power. The CSM's fuel cells, before they died, they'd made water as a byproduct of making electricity. But the LM's batteries, they didn't do that, and they needed both, desperately. They had to cut down the LM's power use to the bare minimum. Swigert managed to get some water across from the command module before they shut it down completely. But Hayes, he figured they'd run out of the water they needed to cool the LM's equipment about 5 hours before re-entry. Interestingly, the Apollo 11 lunar module, it had kept working for hours after its water ran out, and Apollo 13, they ended up coming back with some water to spare. But the crew was on strict rations, something like 0.2 liters per day each. No wonder they lost so much weight. And it probably contributed to Hayes' urinary tract infection, poor chap.
And it was getting pretty rough inside the spacecraft, too. Temperatures dropped to as low as 3 degrees Celsius, 38 Fahrenheit, in the lunar module. It was dark and cold. Lovell decided against wearing their spacesuits. It had been too hot inside the cramped LM. Lovell and Hayes wore their lunar boots to keep warm, and Swigert had an extra coverall. But his feet were always wet because he hadn't been meant to walk on the moon, so he didn't have any overshoes. Even something as simple as going to the toilet became a complicated procedure. They had to store their urine in bags so it wouldn't mess with the spacecraft's delicate trajectory, and there was condensation everywhere, all over the walls. Luckily, they'd improved the insulation after the Apollo 1 fire, so it didn't cause any major electrical problems. Amazingly, despite all this discomfort, the crew barely complained.
As they got closer to Earth, they had to face another huge hurdle: restarting the command module. It had been completely shut down to save those precious resources for re-entry, and this was something no one had really planned for. Powering up a dead CM in space, under these conditions. John Aaron, the flight controller, Ken Mattingly, who remember was stuck on Earth, and loads of engineers, they all worked flat out to figure out how to do it. The astronauts managed to pull it off, a testament to their skill, training, and sheer nerve. Kranz later said their experience as test pilots was key. Those are people used to operating under pressure, knowing their lives are on the line.
And to make sure their re-entry was as accurate as possible, they even powered up the lunar module's guidance computer for a bit, about 133 hours into the mission. That let Lovell take a navigational sighting, recalibrate the LM's inertial measurement unit, the IMU. Then, in a reversal of the usual procedure, they used the LM computer's position and orientation to calibrate the command module's computer. Saved them some steps, and it meant they'd re-enter more accurately. Really clever use of the limited systems they had available.
Now, the final and most critical bit, re-entry and splashdown. This wasn't without its nail-biting moments either. Even though that first trans-Earth injection burn was spot on, the spacecraft was drifting off course. They needed to make more adjustments. The LM's guidance system was offline after the PC+2 burn, so Mission Control told them to use the Earth's day-night terminator line to navigate. That's something they usually do in Earth orbit, but never for returning from the moon. A 14-second burn of the LM's descent propulsion system got them back on track, but they needed another one, 21.5 seconds with the LM's reaction control system thrusters, just before they got rid of the service module.
And when they did jettison that service module, less than half an hour before re-entry, well, it was the first time they got a proper look at the damage. A whole cannel was missing, the fuel cells were tilted and clearly busted, the high-gain antenna was mangled, debris everywhere. Hayes even thought he saw damage to the service module's main engine bell. So Krantz had been right not to rely on that engine. With heavy hearts, the crew moved back into the command module, Odyssey, and switched its life support back on, ready for the fiery plunge back to Earth.
And separating the lunar module Aquarius just before re-entry, that was another tricky situation. Usually they'd use the service module's RCS thrusters for that, but of course the SM was long gone. The engineers at Grumman, they built the lunar module, and some clever folks from the University of Toronto, they came up with a way to do it using air pressure. Worked perfectly. Aquarius re-entered and burned up, its pieces ending up scattered on the ocean floor. And one final tiny course correction took care of the Atomic Energy Commission's worries about the SNAP-27 RTG, that's the plutonium power source. They made sure it landed safely in the very deep Tonga Trench in the Pacific. Helicopters checked the area afterwards and found no sign of any leaks.
Then came the command module re-entry. Tensest times for everyone. During re-entry, you get what they call ionization blackout. Basically, you lose radio contact because of the way the spacecraft interacts with the upper atmosphere. Usually lasts about 4 minutes. But because their re-entry path was shallower, this blackout lasted a full 6 minutes. You can imagine how worried everyone in Mission Control was. They were thinking, what if the heat shield was damaged in the explosion or by being exposed to space for so long? But finally, Odyssey came back online and splashed down safely in the South Pacific southeast of American Samoa, about 6.5 kilometers from the recovery ship, the USS Iwo Jima, at 18.0741 UTC on the 17th of April, 1970. The crew was exhausted, Hayes still had that infection, but otherwise they were in pretty good shape, all things considered. They spent the night on the ship, then flew to Pago Pago, then Hawaii. And there, President Nixon himself awarded them the Presidential Medal of Freedom. Deservedly so, I'd say. The whole mission operations team back in Houston got one, too.
What an absolutely incredible story. What started out as this ambitious mission to land on the moon at Fermaro, well, it turned into this desperate fight for survival. And this whole episode, it really highlights just how much expert problem solving went on at every stage. both from the incredibly resourceful crew on board Odyssey and Aquarius, and from the brilliant minds working tirelessly in mission control. The lunar module becoming this unexpected lifeboat, the navigation they managed with very limited resources and systems that weren't working properly, the sheer ingenuity in keeping life support going, and then that vital restart of the command module, it's all testament to what humans can achieve when pushed to their absolute limits.
Absolutely. Lovell's comment about the amazing cooperation between the crew and the ground teams, it sums it up perfectly. Everyone working together, that's what got them home. Of course, public interest in the space program did get a boost from all the drama, although it didn't last. But I think the real impact of Apollo 13 is much deeper than that. It showed what humans can do when faced with almost impossible odds. The ingenuity, the adaptability, the teamwork, it's inspiring. Now, the official investigation, they found that the oxygen tank problem was caused by damaged Teflon insulation around some wiring. That caused a short circuit, which started a fire. And then there were things like using the wrong voltage during testing and someone dropping the tank before the flight. All these things contributed. It's a stark reminder of just how risky spaceflight is, even when you think you've got everything covered.
And, because of what happened on Apollo 13, they made a lot of safety improvements for all the missions that came after. They completely redesigned the oxygen tanks to fix the problems they found, and they added a third tank in the service module with an isolation valve so that if one tank failed, you wouldn't lose all your oxygen. They also covered all the wiring in areas where it could get damaged and cause a short circuit, and they put in better monitoring systems so they'd get earlier warnings if something started to go wrong. And crucially, they added an emergency supply of water and battery power in the command module just for re-entry, and they improved the way power could be transferred between the lunar module and the command module so they'd have more options in an emergency. All this because of Apollo 13. Shows how dedicated NASA was to learning from their mistakes and making spaceflight as safe as possible.
And at the end of the day, the phrase, successful failure, it fits Apollo 13 perfectly. Yes, they didn't achieve their main objective, landing on the moon.
Yeah.
But they did get all 3 crew members back alive, against all odds. And many people, both inside NASA and out, see it as one of NASA's greatest achievements.
And it really makes you think, doesn't it, about all the little things that had to go wrong to create this crisis. All those points where it could have ended in disaster. Makes you wonder, what if they'd done one thing differently, much earlier on? A different design choice, a more thorough test, even a tiny decision during pre-flight checks. Could any of that have stopped the whole Apollo 13 emergency from happening and let them complete their mission as planned? Food for thought. And if you're interested, I urge you to dig into the technical reports, they're all publicly available, and read the accounts from the people who were actually there. There's so much more to learn about this incredible story of human resilience and ingenuity.
Absolutely.
Right then.
Right.
Until next time.
Until next time.